So hello and welcome back. So in this video I have basically two functions. One of them is a linear function. This one is a linear function, and the general form of a linear function, as you know, is f of x is equal to mx plus b. So in a linear function, m is the slope of the function, and x of course is your variable, and b is your y-intercept. Your y-intercept meaning that, and well, as long as we're talking about this, we could also add that, let's say this is the graph of this linear function, and what this determines, what this b determines, is where the graph of the function goes through the y-axis here. So this is the y-axis, and for example, if this is 1, 2, and 3 here, and the graph of the function goes through the y-axis at this point, then your y-intercept is, your b here is equal to 3. If that is the case, then your b is equal to 3 here. And your m is your slope. So m is the slope and is practically the rise of the function, the rise over the run of the function. What that means is that, for example, if you have a function that whose slope is 1, if your m is equal to 1, then that means that it is equal to 1 over 1. So that means for every unit of run, which is a horizontal measure, for every unit of run you have 1 unit of rise, and the rise is a vertical measure. What that means that, for example, in the case of this function, for every unit of run, that means if I want to run from this point to the next point on the graph of the function, or any other point on the graph of the function, let's say I have to run for 1 unit. So 1 unit would be, 1 horizontal unit would be here. So I will end up here, right here, because this is 1 unit, and 1 horizontal unit basically in the positive x direction. Now, for 1 unit of horizontal run, I have 1 unit of vertical rise, and that basically means that I have 1 unit of one unit of vertical rise here, and then I will end up right here, and that becomes the other point on the graph of the function, and then the function will look like this. So that's the function. So that here the slope of this function is 1. Now if I were to have a function that had the same y-intercept, the same b is equal to 3, but a slope of -1, so -1 basically means -1 over 1. So again, it means for every unit of horizontal change let's say for every unit that you move in the horizontal direction to the right, let's say, you have 1 unit of vertical change in the negative direction, because you have a negative here, and then in that case it would, one of the points of the graph of the function would be this point, because your slope is 3, and then you run for 1 unit in the positive x direction, you end up here, and then you have to rise in the negative direction for 1 unit again, and then you will end up here. And so this becomes the other point on the graph of the function, and this becomes your function. It's supposed to be a straight line. So you can see that here your slope is negative, and here and here, of course, it's supposed to be better than this. I don't know how this happens. And here your slope is positive. So that's all about a that's all about a linear function, which is basically this function right here. So a linear function has a slope, which we talked about here, and has a y-intercept, and the y-intercept basically tells you where the function goes through the y-axis. It could be any point on the y-axis. And you already know about exponential functions. It has a common ratio, which is this r, which we have talked about this in the previous videos, and it has also a y-intercept, or basically if a function g of x is equal to a times r raised to the power x, a is basically the same thing as your b here. So b tells you where your y-intercept is, or where the graph of the function goes through the y-axis. So in this case, again, we have the same story. I have a x-axis here, I have a y-axis here, and so let's say your a here is equal to 3 again. So I have 1, 2, and 3, and so this point, it becomes your one of the points on the graph of the exponential function. And your r basically determines basically your r kind of determines how fast your function is or if I want to tell you in this way, your r is basically, if you divide this 2 by 3, you will get, for example, here you have this term over here. The successive term after 3 is 2. So if you divide this output by this output, you will get a 2 by 3. And then again, if you divide this term by the previous term, you will get 4/3 divided by 2, right? So it's basically nothing but 4/3 times 1/2, which is 4/6, which is 2/3. So again, you have 2/3 here. So this is the common ratio. And again, if you did the same thing here, so for example, 8/9, if you divided this by 4/3, 8/9 divided by 4/3, you would get 8/9 multiplied by 3/4, and that would be, this would be basic simplified 2, and this would be 3, and this would be 1. So again, you would get 2/3. So any two so basically any two successive terms, if you for example, if you divide this term by this term, you will get 2/3 again. Or you could say that this term has been multiplied by 2/3, and then you have 2, and then this, you will have gotten this 2. So this has been multiplied by 2/3, and you will have gotten 4/3, which is the next output. This output has been multiplied by 2/3, and you will have gotten 4 into 2 is 8, 8/9. So this is again the same output. So this factor is repeating itself all throughout the function. 2/3 multiplied by 2/3 multiplied by 2/3, and this way the whole function is made. So basically here, this is called your common ratio. And this is called your, I don't remember what we called it. What I called it yesterday when I was doing the videos. But you can basically, you know that it's simply the y-intercept where the function goes through the y-axis. Is the same thing as b in a linear function. Now, what you need to know here is very simple. So if you want to write down an equation for this function, let's say for this function right here. So here you can see that in the case of a linear function, to get 7 from 5, you are adding 2 to this. So you're adding, basically in the inputs, you're adding always one unit here, 1 unit here, and so on and so forth. The same thing is happening here. In the output, you're adding 2 to 5, you're getting 7. You're adding 2 to 7, you're getting 9. You're adding 2 to 9, you're getting 11, and so on and so forth. So that basically means that for every unit of change, in your input, your output is changing 2 units. And that gives you basically gives you the slope of this function. What I mean by that is that, so basically the slope of, as we talked about it here, the slope of a function, so the slope of a linear function is your rise over your run. And in this function, what happens is that as I add 1 unit to my input, so my run becomes 1, the function is rising 2 units. So it's 2 by 1, which means that m is equal to 2. So now for this function, I know that my m is equal to 2. And I know where this function goes through the y-axis, because I know at x is equal to 0, at this point, at x is equal to 0, I know what my output is, which is 5. So that means this is my y-intercept. So basically my b is equal to 5. So based on these two pieces of information, I can write an equation for this function, which is f of x is equal to mx plus b, and based on these two pieces of information, it becomes f of x is equal to 2x plus 5. So now if my x is equal to 0 here, if my x is equal to 0 here, I will get 2 times 0, which is 0, plus 5, which is 5. And this is the same output here. If my x is equal to 1, I will get 2 times 1, which is 2, plus 5, which is equal to 7, which is the same output here. Now if my x is equal to 2, I have 2 times 2, which is equal to 4, plus 5, which is equal to 9, which is the same output here. So you can see that this is basically the right equation for this function. So this is number 1. And number 2, we have already talked about this here. We found out that our R here was 2/3. So because every term, if you multiply it by 2/3, you will get the next term. Or if you divide this term by this term, you will get 2/3. If you divide this term by this term, you will get 2/3. Or if you multiply this term into 2/3, you will get 8/9. So your R here is 2/3. Your R here is 2/3. And your A here, which is where the function goes through the y-axis at x is equal to 0, is basically 3, because at x is equal to 3, your output is equal to, at x is equal to 0, your output is equal to 3. So your A is equal to 3, if I'm not mistaken here. And the general form of this function is, as you know, g of x is equal to a times r raised to the power x. So g of x is equal to a times r raised to the power x. It's basically the same thing as g of x is equal to a times b raised to the power x. Well, here it's been called r, but it's basically the same thing. Because it's a common ratio, some people call it r, most probably. So basically now I can, based on these two pieces of information and the general form of the function, I can write an equation for this function as g of x is equal to 3 times 2/3 raised to the x power. And for example here, if x is equal to 0, g of 0 becomes 2/3 raised to the 0th power becomes 1, and then you're left with 3, which is basically this output here, 0, 3. If your x is equal to 1 here, your output is 2. Let's see what happens there. If your x is equal to 1, g of 1, then you will have 3 times 2/3 to the first power, which is 2. So when your input is equal to 1, your output becomes 2. When your input is equal to 1, your output is 2. When your input is equal to 4, it's 16 by 27. When your input is equal to 4, you will get, so if this is the function, so g of 4 becomes 3 times 2/3 raised to the 4th power. So 2 to the 4th power becomes 16. So this is 3 times 16 by 3 to the 4th power becomes 81. And this, so 81 is nothing but 9 times 9. And you can simplify this with a 9. So it becomes, this becomes 3 into 9 is 27. So this becomes 16 by 27. So when your input is 4, your output is 16 by 27. 4, 16 by 27. So that's basically how you write these functions based on such tables. And it's a very interesting and good sort of skill to have, but for that you need to understand the nature of those, all of the basically these two kinds of functions. But I think you already know all that. We have already talked about everything that we talked about here. So thank you very much, and I'll see you in the next video. Thank you.